Good morning, students. I am going to start the class, and that is today we are going to discuss the characteristics of PN junction diode. Okay, and is board is appearing clearly, na? Students, write in the chat box. Board and my voice, everything is clear, na? Right. And now this is the y-axis, and this is the x-axis. This is the x-axis, and this is the y-axis. Okay, on the x-axis we are taking the forward voltage at here. This is the forward voltage in the volts. Okay, this is the applied voltage in the forward bias, and the forward current we are taking in the y-axis, that is in the milliamperes, and the forward voltage is on x-axis. Then if you will draw the graph here, we will get like this. And now this is the considered as the point 2, and this is the point 4 volts, and this is the point 6 and point 8 to 1 volt. Okay, on the y-axis we are taking the voltage. The voltage values are the voltage sorry, on the y-axis we are taking the current, and that is a 20 and 40, 60, 80. This is the forward current on y-axis. If you draw the forward bias characteristics graph, then how you will get the graph? The graph you will get like this. You see here, when current voltage slowly we are increasing, the point 2 voltage we are increasing. For example, in case of germanium, if you go for the germanium semiconductor, the potential barrier for the germanium is uh, zero point 0.2 volts, and for the silicon the potential barrier is zero point 0.7 volts. Let us consider now uh, junction diode is made with the our junction diode is made with the silicon. Then the 0.7 is the barrier voltage, opposition volt. हम लोग अप्लाई किया हुआ 0.2 volts. We applied the 0.2 volts. Applied voltage is a 0.2 volts, but opposition voltage is 0.7 volt. If the diode is made with the silicon, then the opposition potential is 0.7. If the diode is made with the germanium, the opposition potential is 0.2 volts. That we know that one. Barrier potential is the opposition potential. And then in order to pass the current through the diode, the applied potential should be greater than the barrier potential, right? That's why when the applied potential is 0.2 volt, but opposition is 0.7 for the silicon, then the current is 0, and zero point 0.4 current is 0 because applied is 0.4, opposition is 0.7. Like this, up to 0.6 zero current will comes. Up to 0.6 the current will be 0. Then after the zero point 0.7, for example, if applied voltage is 0.7, the current starts to increase, and then the graph you will get like this, like this, 0 0 it will comes, and here it will starts to increase, and then the current will be increases suddenly. This is the graph in the forward bias, how current will changes. Okay, you see here, up to zero point 0.7 volt the current will become 0. Up to zero point 0.7 volt the current is 0 at here. This at a particular voltage the current starts to increase. This voltage is called as the cut-in voltage or the knee voltage. Okay, and at this voltage the current starts to increase, right? At what voltage the current starts to increase, that voltage is called as knee voltage or the cut-in voltage. At this voltage the current starts to increase, right? That is the knee voltage for the diode, which is if it is made with the germanium, the new voltage is the zero point 0.7 volts, right? And now in the reverse bias we are taking some values. In the reverse bias we have to apply the more voltage. 20 volts we are applying, 40 volts we are applying, okay, 60 volts we are applying, 70 volts, 80 volts we are applying. Large voltage we will apply in the reverse bias. This is the reverse voltage is on the x-axis, and reverse current is on the y-axis. The reverse current is an y-axis. In the reverse bias, less current will be processed, that we can take as a 10 microamperes and the 20 microamperes and 30 microamperes like this. This is the reverse current. Okay, and the graph if you will try, you will get the graph like this. You listen very carefully. small current will be passes, that is less than 10 microamperes. This small current is due to minority charge carriers, and at a particular reverse voltage what happens, the current suddenly increases. This sudden increase in current sudden increase in current at a particular reverse voltage is called as the breakdown voltage. This is called as the breakdown voltage. Why breakdown is occurred here? Why the breakdown is occurred? Okay. And what is the knee voltage and what is the cut-in voltage? Knee voltage or the cut-in voltage or the threshold voltage? It has so many names. What is that one? In the forward bias it will be that. This is the reverse bias, right? Reverse bias graph, and this is the forward bias graph. This graph indicates the characteristics of PN junction diode. Knee voltage or the cut-in voltage or the threshold voltage. What is this and what is its definition? Okay, its definition is that knee voltage definition is that the voltage, the forward voltage at which potential barrier is eliminated. Opposition wall is eliminated. Potential barrier is almost eliminated. Almost eliminated. Potential barrier is eliminated and current starts flowing. That is called as knee voltage or threshold voltage. Okay, right. The forward voltage at which the potential barrier is almost eliminated and current starts increasing is called as is called as knee voltage or the threshold voltage. At what voltage the current starts increasing, that voltage is called as the knee voltage. And what is the next one is breakdown voltage. How the breakdown occurs? Breakdown voltage. Breakdown voltage. What is the breakdown voltage? This is the reverse bias voltage. Okay. Now, how the breakdown will occurs? Okay, we are discussing about the breakdown voltage. What is the breakdown voltage? Breakdown voltage means when the reverse bias voltage increases, the reverse voltage in the reverse bias voltage at which current increases suddenly, current increases suddenly is called as breakdown voltage. This is the reverse bias voltage. At this voltage, what happens? Current suddenly increases. I will explain why current increases. In forward bias, the reason for the increase in current is that a barrier is eliminated, opposition is eliminated. But in the reverse bias, starting when you will increase the voltage, small current will be flows due to the minority charge carriers. But at a particular reverse voltage, what happens? The current will be suddenly increases. That voltage is called as the breakdown voltage. At this, in the name only it is there. At this voltage, what happens? All the covalent bonds will be broken. At a high reverse voltage, what happens? At a high reverse voltage, At high reverse voltage, when you will increase the voltage, the minority charge carriers kinetic energy increases. Okay, kinetic energy of minority charge carriers increases. Minority charge carriers moves in the reverse bias. Their kinetic energy increases when you will increase the voltage. Kinetic energy of minority charge carriers increases. Then they will go with high kinetic energy and collide with the other atoms. Due to the collision, covalent bonds will be breaks. They collide with what happens at here? They collide with the atoms. Okay, and due to that, covalent bonds breaks and electron hole pairs generated. When covalent bonds breaks, what happens? Electron hole pairs generated. Electron hole pairs generated. When electron hole pair generated, then the current will be increases automatically. Therefore, current increases in the reverse bias because of increase in electron and hole pairs. Okay. What happens once again? I will explain in the reverse bias. In the reverse bias at high voltage, kinetic energy of minority charge carriers increases. This kinetic energy increase means they will go faster and collide with the other atoms. Then due to the covalent bonds breaks, when the covalent bonds breaks, electron holes generates. Then electron hole pair generate means current due to current is due to electrons and holes. That's where current increases. Okay, and then current increases and diode damage. Diode also damages it here. Diode damages, and this voltage is called as a breakdown voltage. Okay, and the next one is the dynamic resistance of diode. Next topic is the dynamic resistance of diode. What is the dynamic resistance of diode? Dynamic resistance of diode means what? Dynamic resistance of diode means it is the ratio between it is the ratio between small change in small change in voltage to the small change in current. Small change in current. Okay, resistance of diode we want. You see here, this is a diode. The diode resistance I want. That is the diode resistance is the small change in. For example, here the change in voltage is delta V. The change in current through the diode is delta I. The change in voltage by change in current gives the resistance of the diode. It's denoted with the small RD for dynamic resistance. Okay, RD. Okay, it's SI unit is ohm only, resistance only, resistance unit is ohm. Okay, right. Next, we will go for the other topic. I am going to explain, and you take the screenshot and note it. I am going to erase this. Next topic is the very important. Next topic I am going to start, and that you will get the one short question in the exam, 3 marks. I think I am expecting. Okay, I am going to explain very important topic now. Number one important chapter, most important what in this chapter, if anybody asks, then that whatever that I am going to start, that is the most important now. That is the topic is rectification. Rectification is the topic. What is the rectification? Rectification means rectification means it is the process of process of converting alternating current into direct current. Okay, the process of converting alternating current into direct current is called as rectification. What is rectification? Rectification is the process in which AC converts into DC. AC means what? Alternating current. DC means direct current. Okay, and the next one is the rectifier. Rectifier means what? Rectifier is a device used to used to convert alternating current into direct current. Alternating current into direct current. Into direct current is called as rectifier. Rectifier is the device. Okay, rectification is the process of converting alternating current into direct current is called as rectification, and the device which converts alternating current into direct current is called as rectifier. Okay, I think you understood everything. What is rectification? Rectification is the process in which what we are doing, alternating current convert into direct current. Rectifier is what? Rectifier is the device which converts alternating current into direct current, right? And these rectifiers are two types. Rectifiers are two types. Okay, the first one is the half wave rectifier. Second one is the full wave rectifier. Out of these two rectifiers, anyone will come in the exam. Very, very, very important in the for the exam. Okay, you listen very carefully, right? And what is our topic? First one, we will discuss about the half wave rectifier. What is half wave rectifier? Half wave rectifier, and draw the circuit diagram and how explain how it will convert AC into DC. That question will come in the exam. Okay, you listen very carefully. I'm going to draw the half wave rectifier circuit diagram. It was very easy. Okay, right. And this is the circuit diagram. We will take the AC as input. AC symbol is this one. This is the input AC. Input AC we are supplying it here. For the positive negative terminals will be changes with the time in the AC. AC means with alternating current. The current whose magnitude and direction changes continuously. Right? That is called as alternating current. This is the diagram for the AC is supplied to the transformer. This is the transformer primary coil, and then this is the secondary coil of transformer, and this is a diode, and we are connecting this one to one load resistance. This is the resistance. Okay, load resistance is RL, and output is taken across the load resistance. Here we will take the output. Okay, this is the output. The output is DC. Input is AC and output is DC. If we draw the wave diagram, we will get like this. This is the P region and this is the N region. And the wave diagram, if we will draw, okay, wave diagram, input AC how it will be there, and output DC how it will be there. This is the input current we are taking, that is the I. Input AC. Okay, input AC will be like this there. The AC current will be very sinusoidally. If we draw the graph, we will get like this. and output DC how you will get. If you will, I will explain how you will get the output, right? And output DC you will get as, I will explain. This is the output DC. Okay, this is the output DC. Now output DC, input AC. Then I will explain the diagram and how half wave rectifier will works. And either half wave rectifier or full wave rectifier. Almost most repeated questions these are. Okay, right. You listen very carefully. And we are starting the half wave rectifier. Right. Very, very important for the exam. Very, very, very up to infinite important. This one. That much important. Okay. Now listen very carefully how half wave rectifier works and what is its construction. If you will see the diagram, right, half wave rectifier consists only single diode. No. Half wave rectifier consists only one diode. Half wave rectifier consists only one diode at here, and then the input AC is given to the primary coil of transformer and output DC is taken across the load resistance. Then how it will works I will explain. You listen very carefully. Okay, right. This is the transformer, and now input AC has the positive cycle and negative cycle. For the positive cycle, what happens? Working I am going to explain how it will works. Right? The working is that very simple. Right? Diagram gives one mark, and the first point in I will give the 2 points in the working. That 2 points you will give the 2 marks during positive half cycle. During positive half cycle means actually input is the this one. Input is at here. Input is this one. Input has the positive cycle and negative cycle. Okay, one wave has positive and negative cycle. During positive half cycle, what happens? During positive half cycle of input AC, during positive half cycle of input AC, okay, and this point, the polarities of secondary coil of transformer we can take as A and B. Okay, sorry, secondary coil. This is secondary coil of transformer. The polarities on both ends we can take as A and B. And when the during the positive half cycle, what happens? A become positive and B become negative. Remember it. A become positive, B become negative during positive half cycle. Okay. During positive half cycle of input AC signal, A become positive, A become positive, and B become B become negative. Okay, and B become negative. When A become positive and B become negative, whether diode PN junction diode, whether it is in forward bias or reverse bias, you can reply for this question. Aditi, increase the size of writing. Yes, sir. Everything is clear. Okay, I will increase. Yes, you see now it will be clear now. Okay, and now during the positive half cycle of input AC signal, during the positive half cycle, what happens? This P terminal is A become positive, B become negative. A is P region is connected to positive terminal, P region connected to positive terminal, and N region connected to negative terminal. Then whether the diode is in forward bias or reverse bias, reply first. Whether diode is in forward or reverse bias, that P region connected to positive terminal and N region connected to negative terminal, then the diode is in forward bias. Then the diode is in then the diode is in then the diode is in forward bias. Right now, forward bias. In forward bias, whether diode conducts or not, yes, it conducts. In forward bias, it conducts means current passes. Okay, right. Conducts, it conducts. It conducts. The current flows through the load resistance, right? It conducts, the current flows through the resistance. Current flows through the resistance, right now current flows through the resistance. Yes, in the very simple, during positive half cycle of input signal, this is the positive half cycle, this is the negative half cycle. During positive half cycle, A become positive, B become negative, and A region connected to positive, N region connected to negative. That means this is forward bias. In forward bias, current will passes. When the current passes through this output is taken at here. Then we will get the output. In case of forward bias, we are getting the output. And then during the negative half cycle, what happens? During negative half cycle, next one is the negative half cycle, right? During negative half cycle of input AC signal, during negative half cycle of input AC signal, what happens? Okay, during negative half cycle, polarities will be changes. This polarities will be changes, this will become negative and this will become positive, remember it. Okay, below you have to take the signs. And then P connected to negative terminal, N connected to positive terminal. The polarities will be reversed now. During negative half cycle, A become negative. P region connected to negative, N region connected to positive, means diode is in reverse bias. Okay, during the negative half cycle of input AC signal, A become negative, A become negative, and B become positive, B become positive, and then the diode is in reverse bias. Then the diode is in reverse bias. It does not conduct in the reverse bias, and it does not conduct, and it does not conduct means current does not flow through it, and it does not conduct means current does not flow through the load resistance. Current does not flow means no output at here for the negative half cycle. Then again positive half cycle comes, the first point will comes, diode conducts forward bias, and for the negative half cycle, diode is in reverse bias, it does not conduct. That means only positive half cycles will be come out, and negative half cycles are blocked in the half wave rectifier, right? And like this, half wave rectifier converts alternating current into direct current. Here you see the alternating current means current direction is changing it here, but positive one time, negative one time, positive one time, negative one time. But here the current direction is not changing, always positive the current direction, means the current direction is not changing. Current direction is not changing means it is a DC current, right? Okay,
उसी को सुधार में सुधार सुधार में सुधार
next one. During the positive half cycle, what happens? During the negative half cycle, what happens? I explained. That means what this half wave rectifier is doing, half wave rectifier converting only half of the input AC signal into DC, half of the input AC signal into DC, only half is converting. Positive of input is converting into getting the output. For the in case of negative half cycles, we are not getting any output. That means negative half cycles are blocked. That means the variation is little bit reduced. Actually, DC current means completely DC current should be like this there. This is the time, and the current, if you will write, the current should not vary, current value should not vary, the you should get a straight line. Current value should not increase, should not decrease, current should be remains constant. Such current is called as DC current. But this is little bit the negative variations are reduced, but not perfect DC, but little bit we can consider it as DC. Okay, like this, half wave rectifier convert into alternating current or AC current into DC current. Then what is its efficiency? Now I am going to continue again, and you take the screenshot and note it. And very very important topic in this chapter, the most important topics are the rectifier concept that we are discussing now. And next, what happening at here, the third point, if you want to give this half wave rectifier blocks DC, blocks the negative of cycles. Okay, negative of cycles of input AC, right? And only, and allows only positive half cycles, right now. And that's why negative half cycles are blocked, means 50% of the power is reduced at here. Now we are going to start, I'm going to start the efficiency of the efficiency of the what is the efficiency of half wave rectifier. What is the efficiency of half wave rectifier? HWR means half wave rectifier. That efficiency formula, efficiency means what? Efficiency means it is the ratio between ratio between output DC power to the output DC power to the input AC power is called as efficiency. Okay, that efficiency formula is ratio between efficiency denoted with eta. It is the output DC power by input AC power. It is the formula for the efficiency. Okay, input AC power. Then but its formula there is there, and that formula is 0.406 RL by RF plus RL. This is the formula for the efficiency of half wave rectifier. Efficiency of half wave rectifier. What is RL in this? RL is the load resistance you saw in the diagram. Across the load resistance we are taking the output. What is RF? RF is the forward resistance of diode. What is RF? Forward resistance of diode. Diode resistance in the forward bias. Okay, this is about half wave rectifier efficiency. And the next one is the what is the maximum possibility efficiency? Maximum efficiency how much? Then that I'm going to explain. Right? You listen very carefully. If you have any query, you write in the chat box. That is the percentage of efficiency I want. Percentage of efficiency. For example, in case of ideal diode, ideal diode not have any resistance. The forward resistance of the diode can be negligible. When the forward resistance is negligible, then you will get the efficiency as 0.406 RL by RF plus RL. RF we are writing 0 at here. When you write RF as 0, when you will write RF as 0, what you will get? RF 0 plus RL, then we will get a 0.406 RL by RL. You will get RL gets cancelled, you will get the 0.406. This is the efficiency. I want the percentage of efficiency. What is the value of percentage of efficiency? Percentage of efficiency is percentage of efficiency you will get by multiplying with 100. That is a 40.6%. That means only 40.6% of input AC signal. Okay, the maximum percentage of efficiency, maximum percentage of efficiency, maximum percentage of efficiency of half wave rectifier. Half wave rectifier. What is why we are telling half wave rectifier? Rectifier is the half wave. Only half wave converting into DC. Now, the full wave means this one positive and input. This is input AC. But output DC having only positive half cycles, means only half converted into DC, but the remaining half is not converted into DC. That's why this is called as a half wave rectifier. Maximum percentage of efficiency of half wave rectifier is 40.6. That means 40.6% of AC converted into DC. For example, if you will give the 100 watt of uh, AC, then you will get output only 40.6 watt. That means total more than 50% power loss in this half wave rectifier, because the negative half cycles are blocked at here. And then if you go for the input and output frequency, what is the relation between the output DC frequency and input AC frequency? Right, if we will go for that, the output DC frequency in half wave rectifier, it is very important point at here. Very important point I am going to explain. Output DC, output to DC power, sorry, not power. I want the frequency. Output DC frequency. Power is we already told, right? And output DC frequency I want. Output DC frequency I want. Output DC frequency. Any query, students? Any query? Are you getting the points? Output DC frequency. Output, are what happened? Output DC frequency is equal to the input AC frequency. Output frequency, input frequency is the same, right? Output frequency, input frequency, how it will be same? This is the input. For example, input we have the two waves. And what about the output? Output also have the two waves, right? This is one and this is the next one. It is also have the two waves. That means output frequency is equal to input frequency. This is input AC and this is the output DC. Output DC frequency equal to the input AC frequency. This is about a half wave rectifier. Any doubt? It is completed half wave rectifier. Next I am going to start the full wave rectifier. I am going to start the full wave rectifier. If you have any query, you can ask me, right? Going to start. Rectifier means what? Rectifier is a device which converts alternating current into direct current. Rectifier is a device which converts alternating current into direct current. Now, rectifiers are two types, half wave rectifier and full wave rectifier. Half wave rectifier converts only half of the input AC signal into DC and the negative half cycles are blocked by half wave rectifier. Next, we are going to, in the half wave rectifier, we are using only single diode. In the half wave rectifier, we are using only single diode. Next, I am going to start the full wave rectifier. What is full wave rectifier? Both input positive and negative half cycles of input AC signal converted into DC. In this full wave rectifier, okay, we use the two diodes, right? Listen very carefully, very important. Full wave rectifier. In exam, it will comes. I think pre-board. You have the pre-board from, I think on Monday onwards, right? You prepare properly. Full wave rectifier. Full wave rectifier. First exam is the physics, na? Full wave rectifier. What is a full wave rectifier? And what it will do and how it will converts and how it will works. That all things I am going to explain. At first diagram, circuit diagram. Input AC we are giving to the primary coil of transformer, right? And this is the input AC, okay? And this I am connecting to the primary coil of transformer. This is the secondary coil of transformer. This is the first PN junction diode, diode 1, D1, and this is the diode D2. Two diodes we have to use it here. They will be connected like this. Then after that, from the center tap transformer is used at here. Okay, center tap transformer. Center, from the center also one terminal we will take. That will be not connected at here. And from this one end we will take one wire, and here we will connect to the one load resistance. One load resistance. And across the load resistance we will take the output we will take it here. This is the output DC. Output DC. Input AC is supplied at here, output DC is taken at here. This is the circuit diagram of the full wave rectifier, and this is the secondary coil of the transformer. This is a transformer. Which type of transformer is used? Central tap transformer is used. Central tap transformer is used means uh, from the center also we are taking one terminal, right? And this wire from the center it is coming, and that is not in contact with this, right? Okay, this is the P region and this is the N region. P region and N region. And how this will convert half wave rectifier into full wave rectifier, I will draw the wave diagram. Okay, for that you have to take very carefully, you have to hear. I think everything is clear now. No doubts. Input AC signal, right? And the input AC signal is will be like this there, right? AC will be like this there. AC is in the wave form, right? And the current is taken on y axis, and this is the time is taken on x axis. This is the graph for the input. With the time it will be current increases, next decreases, oppositely increases, next decreases. This is alternating current. Alternating current means always current value and direction changes. Okay, and this is the alternating current. And now what about the output form? How you will get the output? Output DC. Output DC. Input we are giving to the primary coil of the transformer, and output is taken across the load resistance, and central tap transformer is used. In these two diodes we are using. And in case of positive half cycle how it will works, and in case of negative half cycle how it will works, and that we are going to discuss. You listen very carefully. Right, let us start. And first, for the positive half cycle, during the positive half cycle what happens? During the positive half cycle, working I am going to explain. In the working, just very simple points we have to explain. During the positive half cycle what happens, and during the negative half cycle what happens. The most of the times they ask the question that what is a full wave rectifier, and draw the circuit diagram and explain its working. In the working, 2 points are there, diagram 1 point is there, and total 3 marks are there. You will get in the exam 3 marks. Just one diagram is this one, and the working how it will work, 2 points I will tell. And during positive half cycle what happens? Okay, if you want the construction, the full wave rectifier has two diodes. Okay, and in this central tap transformer is used. Input AC is connected to the primary coil of transformer. Output DC is taken across the load resistance. RL is the load resistance. Working starts now. During positive half cycle what happens? During positive half cycle of input AC signal. Input AC signal. What happens? Very simple. Right? A become positive, B become negative. Right? A become positive, B become negative. This is A and this is B. A become positive and B become negative. Very simple. Right? A become positive, comma, B become negative. During the positive half cycle, A become positive and B become negative. A become positive means P region is for the first diode. Let us see whether it is in the forward bias or reverse bias. To tell the question, that one question I am going to ask. During the positive half cycle, A become the positive. A become positive during the positive half cycle. For this, A become positive and B become negative. And now whether the diode D1 is in forward bias or reverse bias. What about the diode D2 condition also? Same thing you can tell whether the diode D1 is in forward or reverse bias. Okay, P region of the diode is connected to positive terminal. N region, you see the diagram. Okay, follow the diagram cursor. P region is connected to positive terminal, N region connected to the negative terminal. When P region connected to positive terminal and N region connected to negative terminal, then the diode is in forward bias. We tell the diode D1, the diode D1 is in forward bias. Diode D1 is in forward bias, means it conducts, right? Diode D1 is in forward bias and it conducts. What about the diode D2 condition? And diode D2 is in reverse bias. Why? Because the P region of diode D2 connected to negative terminal, N region is connected to positive terminal. You see the figure and follow the cursor, right? P region connected to negative terminal and N region connected to positive terminal. That means the diode D2 is in reverse bias. Remember that P positive, N negative means that is forward bias. P negative, N positive means that is reverse bias. In the reverse bias, diode not conducts. Here D2 P region connected to negative terminal of battery, D2 diode N region connected to positive terminal of battery. That's why the diode D2 is in reverse bias. Right? One is in forward bias and other is in reverse bias. Now, which diode will be conducts now? Diode D1 is in forward bias. That's why D1 will be conducts. Current flows through the load resistance due to diode D1 because D1 conducts. Now the current flows through the load resistance due to diode D1, right? Due to diode D1 the current flows, that means you will get the output. The output you will get like this. Right? Is it clear, students? Twinkle. Yes, sir. Okay, if you have any query, write in the chat box. Next, second point I am going to explain. This is the during positive off cycle. What happened? During positive off cycle, A become positive, B become negative. Diode D1 is in forward bias, D2 in reverse bias, D1 conducts. Through the D1 current flows that will be goes outside and it will passes through load resistance that is taken output. That's why we are getting in the output. What about the negative off cycle? During negative off cycle, we have to write. During negative off cycle, polarities will be changes. During negative off cycle of input AC signal. Input AC signal. A become, actually what happens? Reverse it will be. Now A become negative, B become positive. A become negative, B become positive. Polarities will be changes because cycle is changed, current direction is changed. That's why polarities also changes. B become positive. Then what happens to the diode? The diode D1 what happens? Diode D2 is in what happens? Then when this area become negative means P region diode D1 P region connected to negative terminal, N region connected to positive terminal. Okay, look at here the second sign downward you have to see. Okay, follow the cursor in the figure. You look at the figure. This is the negative terminal. This is the positive terminal. A become negative, B become positive during the negative off cycle. P region of the diode D1 connected to negative terminal and N region connected to positive terminal. Then the diode D1 is in reverse bias. The diode D1 is in reverse bias and the diode D2 is in and the diode D2 is in forward bias. Diode D2 is in forward bias means what happens? D2 conducts, look at here. D2 conducts means current passes, diagram you see. Current passes through the diode D2 like this, like this, like this. Current passes and it passes. This side diode towards diode D1 it not passes because D1 not conducts because D1 is in reverse bias. In the reverse bias, current not flows. Okay, then the current will be same direction. It will comes during the negative off cycle also. In the output, you will get the positive off cycle like this. The current flows again In this case, current flows through the load resistance, due to D2. Why D2 diode? Because D2 diode is in forward bias. Which is in forward bias, through that current will be passes, right? And like this, during positive half cycle, diode D1 conducts. D1 is in forward bias. During negative half cycle, diode D2 conducts. Like this, for the positive and for the negative, for the both, you will get the output. That means it is said to be full wave rectifier, because it is converting the full wave. Positive it is converting and negative also converting. That's why it is said to be full wave rectifier. This is about working of full wave rectifier. Okay, in the exam, if you will draw the diagram and you will give the 2 points in the working, you will get the 3 marks. Okay, this is most important question. You practice properly. Okay, if you have any doubt, you can ask me. You can write in the chat box. Okay, right, more 10 minutes I am going to continue the class. This is about working we discussed now. Next, I am going to explain the efficiency of the full wave rectifier. What is the efficiency of the full wave rectifier? Next one is the efficiency of full wave rectifier. Oh, not efficiency. One more point I am going to do. In this, what happens? Third point is that in full wave rectifier, output in full wave rectifier, output we are getting the DC now. That output DC frequency is 2 times of input AC frequency. 2 times of input AC frequency. Why the frequency is doubled in the output? I will explain. You see here input AC. This is the one wave. We will tell one positive and one negative cycle. It is called as the, this is the positive half cycle of input and this is the negative half cycle of input. This is input AC, alternating current. Then if you will go for the DC, in the DC what you are getting? In the DC, for the positive half cycle you are getting the positive, right? For the negative also you are getting the positive. That means here they are having the one wave, one positive, but here we have the two positives, right? Two positives we have in the same region. That means in the input AC, one positive is there. In output DC, two positives are there. That means the number of waves are increased in the DC, output DC. Okay, right. That's why output DC frequency is 2 times of input AC frequency. Okay, right. Next one is the efficiency. What is the definition of efficiency? It is the ratio between output DC power to the input AC power is called as the efficiency. The efficiency of full wave rectifier is, it is a double of the half wave rectifier. It is a double of the half wave rectifier. Right, efficiency formula is what? DC output power by AC input power, and the formula is 0.812 RL by RF plus RL. This is the formula for the efficiency of full wave rectifier. What is RL in this? RL is the load resistance and RF is the forward resistance of the diode. RL is the load resistance and RF is the forward resistance of diode. Forward resistance. of diode. Now, for example, in case of ideal diode, ideal means it does not have any resistance. Okay. In case of ideal diode, what we have tried it here, we have tried the forward resistance of the diode is 0. It is negligible, right? Then when you will write that one, what you are getting the efficiency 0.812 RL by 0 plus RL we will get, and that is nothing but 0.812. This 0 plus RL will be cancelled, 0.812 you will get. If you want the percentage of efficiency, what you will get, you have to multiply with 100. That means 81.2% you will get. Right? The maximum percentage of efficiency of full wave rectifier is 81.2%. That means what happening here, input 100 watts power, if you will give output 81.2 watt you will get, its efficiency is only 81.2. that means it converts 81.2% of input AC into DC, right? That means what about the 18.8%? We are giving the 100 watts input for the full wave rectifier, it is giving output only 81.2 watt. The remaining is converted into heat energy. Then some of the loss of energy is there. This is about efficiency of full wave rectifier. Okay. Okay. This is the this is about half wave and full wave rectifier. These two are the very important topics in this chapter, and more half an hour required to complete this chapter. Okay, if possible I will take in the evening. Okay, we will close the syllabus. On the Monday you have the pre-board exam. Okay, you prepare properly for the physics and start the revision. In one day it is not possible to complete the whole syllabus. Okay, 2-3 days preparation continuously required. You start the preparation from today onwards. If you have any doubt, you can be you can contact in the WhatsApp. Okay, or you can make a phone call, right? Okay, prepare properly. I am closing today's lecture.